Hello, everybody, and welcome to our webinar today. I just wanted to thank you all for making time. We're really excited about this announcement. We officially launched at World of Concrete. Got a lot of good feedback there, but now you can actually go out and buy the product. So I figured it was time to get on and show everybody what we've been working on the last 6 months. So with that, let's kind of take a look at the housekeeping side of things. So again, everybody is going to be muted during the presentation. Please ask questions via the chat. If you just hop over into the little sidebar, there's a chat section. You can ask us questions through there. We will have a Q&A session at the end, and we will try and get through as many of those questions as we can. And the webinar is being recorded. We will shoot that link out after the webinar is done. Usually we do it about a week after. So if you have to drop off halfway through, or if there's somebody else you think needs to see it, give us about a week to get that published. So with that, do a quick introduction. I am your host today, Kelly Cohn. I'm the VP of Product Management here at ClearEdge 3D. My background was 10 years in the industry, working at the Beck Group as a BIM VDC manager for most of that time. And actually, one of the reasons I came to ClearEdge was trying to solve this problem of QA/QC out on the job site. So, as we brought Verity to the market, and we're getting some really good feedback on that as a QA/QC tool, it was exciting to see our other panelist, Philip, doing a very similar product that focused on a very different workflow. And so, we'd been following pretty closely what Philip was working on with Rithm, and had been doing quite a lot of talking with them over the years, and that's why we've got Philip here with us today. Say hello, Philip.
Hello, yeah, thanks for that, Kelly.
Yeah, and as you can see here, I actually learned something new about Philip today. Not only can he solve a Rubik's Cube in 35 seconds, he actually used to break dance. So that means we have two people that used to dance on the webinar. Two geeks that used to dance. That's pretty unusual. But Philip co-founded Rithm, and then has also co-founded Struction Site, which is their new company. They've got a really great product for 360 photos, managing those, viewing them, for all sorts of great workflows on the job site. They also have Rithm. And we'll talk a little bit in a couple slides about the partnership that we have. But and then last we have Zoltan Ferenczi. So Zoltan is, gosh, Zoltan, when did you join ClearEdge? It was coming up on 6 months now?
Yeah, I think back in October.
Yeah, so getting close to 6 months. So Zoltan's got loads of experience in the industry. We brought him on board to kind of supplement our industry knowledge, and he took a real lead in getting the Rithm product ported over into Verity because he'd had some experience running Rithm in his prior life. So that's the three of us, and we'll be running through the agenda today, kind of going back and forth as a team. So the first thing we wanted to dive into was why you might want to use laser scanning for QA/QC, and specifically for floor flatness workflows. So, there are a lot of ways that are already out there to collect this data. People are, of course, probably familiar with dipsticks used for, the ASTM 1155 standards, kind of walking those lines and picking up points along the way. People are also usually familiar with using total stations to go out and collect grids of points, things like that. And all of these are really good, accurate, viable ways to collect this data, but they come with some limitations, and they are all kind of broken out into these different workflows with different pieces of equipment. So there's a lot of benefits in utilizing a laser scanner, of course, because you can go out and collect the data once, and then you can use it to do all these different types of analyses and reports, whether it's for the floor, whether it's for beams, whether it's for walls, whatever it may be. You kind of capture everything, and then you get to use that downstream in multiple different ways, using one piece of equipment to kind of pick up all that information. So there are lots of really good reasons to leverage laser scanning for these kind of workflows. But laser scanners have always been pretty expensive, of course, and the software, I think, historically has been a very kind of geospatial centric solution. And so the software has really been built up around all these kind of different uses that aren't really core to vertical construction. And so one of the things we really liked about Rithm was the fact that it was actually targeted at a very specific workflow, or a couple of workflows. And it really kind of was built around what the needs were for that particular workflow. And Philip coined a term for this, minimum viable workflow. So something we repeat now and give Philip props for. But that kind of generic nature of the software, I think, also really put the burden on us as kind of end users to figure out how to make the software work for what we needed to get the reports out that we needed, to get the information that we needed. And that took a lot of effort, a lot of tweaking, and it kind of took a very patient person like Philip to kind of figure out how to work through those issues and get a result. And of course, those are the things that drove, I think, probably all three of us presenting today to move to the software development side of the industry to try and provide solutions that solve problems in a way that mattered for us. So with that, I'll ask Philip to unmute himself. And basically, we, about 6 months ago, were working with Philip and Matt over at Rithm, and decided that we were going to license the IP from those guys and build that functionality into our Verity platform. And so we've licensed that IP from Struction Site, and the last 5 to 6 months we've been integrating that into our technology so that we can kind of pull the Rithm workflow out of Scene and get it into something that's a little bit more accessible to most of the people in our markets. Particularly in the United States, in the form of Navisworks. So, Philip, I don't know if you wanted to say anything about that.
Well, I think it's such an amazing move, something that I've personally wanted to do for a while. But being able to get to the market in that way through a partnership with ClearEdge was just such an amazing way to do that. I've always wanted, and we have always believed that it's important to be hardware platform neutral, workflow neutral, because lots of different companies and software companies are constantly innovating. So by enabling access to Rithm through Navisworks, it really opens up the doors and allows people to focus on the deliverable, which is at the end of the day the most important thing. So working with ClearEdge was really exciting. Was drawn to them 8 years ago when I worked in construction, and just saw the experience and passion they had for the industry. People like Kevin Williams, the amazing computer vision scientist, having people like Kelly Cohn, Zoltan on there with industry experience. It's really complementary to Rithm in terms of truly knowing where the work is and how it gets done. It's like the yin to our yang. We really complement each other. ClearEdge having best-in-class workflows with BIM creation, verification, Rithm focusing on everything else outside of that in terms of building code analysis and QA. So it's a match made in heaven. Saw that pretty quickly.
So it's been really exciting for us, and I think it would have taken us years to try and code all this stuff up ourselves. So this is one of those. I think what's the term people use? Cooperation or something? It's cooperation and competition, mishmash together. But like you said, it was a really good fit. So we're gonna dive into a demo pretty quickly. I know that's probably what people are most interested in seeing. So we're not going to talk much longer. I do want to do 2 quick slides to kind of highlight some of the real key values of using this software. So, you know, as I mentioned earlier, once you have all this data collected, now you can bring that into Navisworks, which is a software you already most likely have. And then you can run Rithm on any laser scan data that's brought into Navisworks through the RCS or RCP formats. And it can be structured, it can be unstructured. Historically, ClearEdge software really likes structured data. This particular set of algorithms does not need structured data, so it can be unified. It can come out of a mobile scanner, though, you know, with a decrease in accuracy. And so that's really great. I think the other real big benefit is this gives you the ability to do most of these floor flatness or FFFL tests, all these different things in 15 minutes from scan to finish. So you don't have to wait a whole day or, you know, an entire morning just to get results back from a third party that you hire to come out with a dipstick and run a couple lines on a dried slab. You can actually go out there while the concrete's wet, run your scans, get feedback, and while the concrete's still plastic, while it's workable, you can make adjustments to make sure you get down to the levelness that you need to actually pass your requirements. And this is something that is you know, conforming with the known industry standards. So you know, Philip spent a lot of time and effort working with the ACI to make sure that this basically the methods that were used are compliant with the ASTM E1155 standard. So you don't have to worry about that. It's actually approved. It just works. You can also go through a lot of different visual reporting mechanisms like elevation maps, and we can also do contour lines. So all sorts of different things that we'll show you here in a few minutes, or actually at the next slide. And this ultimately means you can own that QA process yourself, get the results very quickly, and make your kind of decisions based off that information, not be sitting there waiting for days to try and figure out what you need to do, or even waiting for the concrete to dry before you go out and test it. So lots of advantages to getting that decision-making process moved up earlier in the chain. And with that, we will go ahead and make Sultan presenter here. Now we can get to the fun stuff.
All right, hopefully you guys can all see my screen. So as Kelly was saying, the floor flatness workflow in Rithm starts off in Autodesk Navisworks. It's the platform in which we can bring in laser scan data from just about any manufacturer through the recap format, and then have Navisworks act as a platform for hosting the analysis. What's important about this is not only since you typically already have Navisworks and are familiar with it, other people that are interested in this information as well also typically are utilizing Navisworks. And so this becomes a communication tool for this information as well as the analysis tool. So here I've brought in a simple laser scan of a floor, and I've isolated just the floor area by using a clipping box so that we can start to analyze this inside of Rithm. So I'm going to give this a save, and then let's open this up in Rithm, and we will look at how we can do concrete floor flatness analysis. So the Rithm application kind of works side by side with Navisworks. It takes data from the Navisworks model and analyzes it in Rithm, and then we can bring that information back.
So this is actually using the Verity framework. So a lot of the things that you would expect with Verity, if you're an existing Verity customer, Those kind of things are also true. It's great to run it on 2 monitors. You can kind of see the 2 side by side. We've got some view synchronization, all those kind of things that exist in the Verity platform now exist with Rithm as well. But it still takes a minute or 2 to load a lot of dense point data, and there's no speeding that up.
Well, there is. It's just going to come out in a future release.
Well played.
Okay,
right.
So here inside of the Rithm application, we essentially have 2 toolbars for analysis workflows. We've got one that's specifically for concrete flatness analysis, where we can do heat maps and contour maps. Soon we'll be able to do wall heat maps as well, and also analyzing points or grids of points, and then soon we'll be able to also monitor changes that happen across different laser scans, and also beam camera analysis is happening pretty soon as well. And then the second toolbar is essentially for the ASTM reporting and ADA compliance analysis. So I'm going to start by going through a workflow to do a heat map to visualize the elevations on this floor. But before I create the heat map, I'm going to run this debris filter. And what that's going to allow us to do is it's going to isolate the areas of the floor that are not the actual floor surface. So typically in as-built floor scanning, after the concrete has set, people have already started to move equipment out onto the floor. There can be little piles of dirt or extension cords or whatever else. And what this debris filter does is it will isolate just the floor surface and remove anything that's not part of that floor surface. So this is a really good way to kind of prepare the point cloud to get it to where we can analyze only the floor surface and not things that are extraneous to the floor. So here we see that the debris that it is isolated is shown in red, and these will not be part of the analysis. So I'm going to go start by creating a heat map. And a heat map is a way to visualize the elevations of the floor graphically using colors. There's 2 ways to do this. You can either visualize high and low areas where we give elevations colors, or we can visualize cut and fill areas by specifying that everything above and below a certain tolerance is either a cut or a filled area. So I'm going to analyze high and low area. We can do it in absolute or relative elevations, and we can specify a base elevation if we want to take measurements from a certain benchmark. What this is going to do is for every elevation interval, and I've set that to 1/100th of a foot, it gives us a colored representation of what that absolute elevation is. And we can see it here. The highest area in this point cloud is about 100 feet, and then it slopes down to about 99.9 feet as we go away from this kind of lump right here. As you can see, this is not a very flat floor at all. You can see that there's a kind of a lump here in the middle, and then it slopes off here. What we can utilize this information for is for that wet concrete workflow that Kelly was talking about, to very quickly take the scan of the floor while the concrete is still wet, and then visualize the high and low areas, and then instruct the people screeding the concrete where the high and low areas are, and then scan it again and analyze it again, and continue that process until the required flatness has been met. Now, beyond that, we can also communicate this information. So this point cloud, I can export the heat map points into an XYZ file that I can then index and recap again, and bring those back into the Navisworks model so that we can then communicate that information to anybody who is interested in it. So here I'll bring in the heat map for the analysis that I just did. Typically, you would export it out as an XYZ, bring it into Recap, index it into an RCS file, and then link it into Navisworks. Once you have it in Navisworks, then you can publish this model as an NWD so that you can communicate that information to anybody who's interested in it and use it as a visualization tool for anybody who doesn't have Rithm available. So there we see the heat map information in Navisworks. So heat maps are very useful in being able to visualize these high and low areas graphically so that we can communicate this information very clearly. But also we can make a bit more usable information for this by creating contour maps instead of heat maps. Contour maps are like topographic civil site drawings that you typically see. They're using CAD geometry instead of just the colored points, and we can then utilize these in the same way that you would for any other topographic elevation. We have the same settings that we do for the heat map. We can visualize high and low areas or cut and fill volumes. And then when this information is created, instead of just being visual, this is CAD geometry. So we're actually going to get line work from this. And that line work can then be exported in a DXF format and then given to anybody in the downstream parts of the design chain, and they can utilize that information in AutoCAD. They can bring it into Revit to create an as-built topo surface or anywhere that contours would be used. So here we see the contour lines. It's the same information that we saw before, but instead of having just colorized areas, we have information that we can then share in kind of computable format, since all of this can export as DXF format. So other things that we can do, we can analyze points more specifically. If we're interested in very specific, let's say high and low points, I can create any number of points and specify whether I want to display eastings, northings, elevations, and then I can locate these points for the purpose of, let's say, marking a high point over here, stick a low point over here.
I can always tell, Zoltan, when you've spent a couple days messing around with code because you start your labels with 0 instead of 1.
That's right. It's, us diehard programmers will always zero index everything. All right, and then when we're done creating these points, these can act as inspection points. What we can use these for is we can export this information as CSV files, and then that information will then get into a total station for the purpose of laying those points out back out in the field. So another way to do this, instead of just creating the points individually, is I can create a grid of points. We'll give them a descriptor. We'll start with the proper starting number, and then we'll specify a spacing between these points. And then I can easily pick the location of the first point, the location of the last point in the row, and then the direction that the columns go. And then these inspection points can then act as something that we can use for reporting. So now we're essentially taking a sampling of elevations at the floor at every 5-foot intervals. And in the same way, we can visualize these by elevation colors or any other information that's required.
And for those of you that might be existing Rithm users, you'll probably notice that it looks like Rithm, it feels like Rithm, it tastes like Rithm. This is quite literally the Rithm toolbars, the Rithm application running inside of Verity. So you know, if you're coming from that platform, as you can already see, this is going to be no-brainer if you've got experience with it, picking it up and running with it here. Basically all the same tools, buttons, and workflows.
Yes, and so once we've created these points, we can export them out in, like I said, CSV format, load them back into TotalStation for layout purposes, or we can create PDF reports that we can then share this information. And also, coming soon in the next half release, this information can be used for monitoring purposes. So what we can do is, if we scanned a concrete floor before it gets loaded by some structural loading, we can then scan it again after the structural loading, and then each of these points will then report a difference of elevation, so how much the floor has deflected at each point. So the last thing I'm going to show is the ASTM E1155 floor flatness report. This is really what this software is all about, because as Kelly was alluding, typically this is done by a third-party outsourced provider that usually have to schedule them a couple of days in advance. They come out with a dipstick. They then spend a couple of hours walking this thing along the floor, along a line that you want to measure, and then they go away, and another day or so later you get a report. That exact same report that you can get from that third-party consultant, we can produce right here using the point cloud just by picking the locations along the floor where I want to take the floor flatness analysis. And then it will analyze the point cloud at those required increments to produce the exact same report that is in the ASTM standard. So you can essentially internalize this process and not have to rely on the schedule and the cost of a third-party provider. So I've picked 2 points, or picked 2 lines along the floor, along which I'm going to analyze the flatness and the levelness, and then it will analyze the point cloud at every 12-inch increment and produce an elevation profile for the flatness and the levelness of the floor at those intervals. And so here we see I have a floor flatness and a floor levelness value for each of these analyzed lines, and the report that comes out of this is the exact same report that that third-party provider would hand you. So if your customers are requiring your floors to be built with a certain flatness and levelness requirement, then you can provide these reports, and they can be confident that you've met that requirement.
Now, if you're a ASTM E1155 expert and you're watching, I'm pretty sure the lines we drew don't actually conform with the standard. This is a quick demo, but you can, if you know the standard, you know roughly where those lines need to be relative to slab edges, penetrations, the length that you have to have. There's some tools in here that will kind of make sure that you don't have a line that's too short. If Philip wants to, when we get to Q&A, maybe we'll talk a little bit about some enhancements that are coming to Rithm at large, but to improve upon this even further. But yeah, it basically lets you draw the lines the way you know they need to be drawn, and then get the reports you expect to get out of them.
Yes. And as I had mentioned, there are some additional features that will be coming out very soon in the first service pack release, such as doing beam camber analysis when steel beams that support a floor are designed, they're designed to camber a certain amount when the concrete is poured. This tool will report that amount of camber, and you can actually monitor the changes between a pre and post poured concrete slab to see how much the beam cambers between those two time frames. And also a complete set of ADA analysis tools for analyzing slopes and ramps and other things that are required for ADA compliance. So those will be coming fairly soon. And Philip can talk a little bit more about that.
Yeah. Well, and we'll just, since we've mentioned it 2 or 3 times, the next release is scheduled to be out sometime next week. And that'll be a service pack with a bunch of new additional functionality here. So we're gonna try and get that out the door as quickly as possible. So we have all the same buttons, and they're all working, not just saying coming soon.
Yep. All right, well, I'll turn it back over to you, Kelly.
All righty. I will see if I can make myself presenter again. There we go. All right. So with all the goods out of the way, I think we're just going to dive straight into Q&A. So I'll expand the chat window here and see if anybody has any chats or questions. And let's see, we already got a couple of them in here. Let me pop this out so I can see a little more. There we go, perfect. All right, so we are interested in flatness and comparison to datum, but also regularity. Does the tool allow measurement of deviation under a rolling flat edge? Philip, actually, that sounds like a fantastic question for you.
So the question was, can it analyze?
They're trying to, I think, replicate a regularity test using a rolling flat edge, as opposed to a grid of points or heat map or contour.
Right. Yeah. I think that sounds familiar to the there's a machine called a D-meter that has wheels in the field. They call it the walking the dog. It has wheels and they walk it. It creates a profile and it looks for irregularities in the floor. It essentially creates a profile along where it runs. Maybe does that sound like it's describing that workflow? Kelly?
It wasn't super specific here in the question. I don't know, Martin, if you want, you can add an additional question to clarify.
But that's if that's the case, though, it does. I mean, the running the F number lines, as Zoltan just showed, that actually does replicate a machine that essentially rolls on the floor and looks for surface irregularities along a certain profile. That's actually exactly what the ASTM E1155 runs are. It's a profile, so I think it does similar things to what might be described.
Excellent.
Yeah, I'm going to say that does sound very similar to the Q values that are typically reported by floor flatness and levelness. So floor flatness and levelness is really two things. Levelness is how much it deviates from being not a horizontal floor, and flatness is that irregular contour that you're talking about, and the samples along the analysis line measure the changes in angle, which become these Q values, and that determines the FF number, the floor flatness number.
Awesome. We've got a question from Christian Hubbard. Are you hearing about how those in the concrete industry are utilizing this data to prepare for a pour? In other words, are you finding that this information is helping anyone in preparation? So that's an interesting question. I have not known anybody using this as kind of a pre-pour prep. Philip, have you heard anything?
Oh, yeah, I definitely have.
Excellent.
Well, so you can actually, using creative workflows with the heat map, the heat map in Rithm actually allows you to compare against a known or a desired elevation. You can manipulate it so that, for example, you can see are any parts of the rebar, not going to get enough coverage, not the 1/4 inch to 3/8 of an inch coverage when the mud is poured. Or I've also seen people check the formwork elevation, not just to see is it the right elevation, is it cambering upward according to the engineering design, because after it's poured, it takes on the load, it's supposed to become straight. So there's a couple of things there that not obviously not using the F number analysis, but using a combination of the heat map and the monitoring of points to check elevations. You can even with what I believe Kelly said it was coming out next week, when you can monitor the point movement, you can actually creatively find out what the deck thickness is predicted to be based on where a point is, according to the scan, to where it's supposed to be in design, and are you matching that deck thickness, which needs to be, from my understanding, plus or minus 3/8 of an inch according to ACI guidelines. So there's definitely plenty, and I know people that are scanning like 5 times the same slab before the pour, during, after, so it's pre-pour. There's definitely a lot of use cases there and deliverables that can be made with the Rithm workflows.
Awesome. That's actually fantastic. I had not heard of those before. So, all righty, learn something good there. I've got a question. How is this process more efficient than producing the floor flatness while working on recap? So you can get some basic heat mapping, elevation mapping out of recap, though it doesn't work very well at very small numbers, from my experience. But outside of that, you're not going to be able to generate FFFL numbers out of recap. You're not going to be able to generate contour lines out of recap. So the key thing here is that we're able to do much more detailed analysis, and probably even more key, reports that are actually designed for these different workflows, whereas recap is a much more generic tool.
Yeah, and also the key here is the speed of the workflow. You can create visualizations of the elevations of points in recap, but to narrow that range down to a small enough range to give meaningful information on the floor, and then this also doesn't take into consideration any noise or dirt or things that the debris filter would remove. It's just setting that up in recap is a bit more time consuming. And then once you have that, the colorized elevations in recap are just a visualization. You can't export a point cloud that has those colors baked in the way that I exported the heat map back to Navisworks from Rithm.
Yeah, I'd like to add another thing to that is you run a heat map with Rithm, and you can export it, like Zoltan said, as a full actual point cloud. So this is very important when you're creating deliverables. You ever try to create a deliverable from heat map point cloud data in Revit or AutoCAD? It actually creates a true vector PDF export and not just a screenshot of the heat map. So you can actually zoom in very close. You can look in individual rooms, see the door swings, and that point cloud looks really beautiful with the heat map created with Rithm, which you don't really get with most of the software, definitely not in recap, where you actually have to do like a kind of a screen grab, essentially, which is low resolution.
Yeah. All righty, had this question. If the scanner is only accurate to a certain amount, i.e. an 1/8 of an inch, how can it comply with the ASTM 1155, which requires the 1/100th of an inch accuracy? Philip, I'll put that one to you.
Yeah, so the reason why Rithm is named that way, it's short for algorithm. And algorithms is the reason, and sampling of dense data. So I've helped write and push the 2014 revision of ASTM 1155. So it's essentially guarantee that, I mean, the algorithms behind will match it. So yeah, most scanners these days they're only accurate to an 1/8, maybe a 16th at most. But the requirements for ASTM 1155 is actually much higher. If you have a certain number of points and density of points, you can actually plot that statistically and guarantee 95% confidence interval that you're going to be within 1/100th of an inch. And actually, you can actually derive higher accuracy from lower accuracy data by having more data points. This is a well-known statistical thing that people use in other sciences and industries. And we field tested this, found with many companies doing as direct side by side, looking at the same lines, we were able to get within 1% of accuracy of a traditional dipstick. As for repeatability, that's still something we're trying to explore, and really depends on the workflows. When you have a dipstick person go down the line, they're as a quality manager, I know used to say they're as straight as they are sober. When you're actually doing F number runs with Rithm, they're perfect lines. So there's some potential repeatability when you're comparing to traditional methods, but if you're actually sampling the exact same lines with the same workflow, following best practices, you're going to get very accurate results there.
Well, the key thing there is that it's actually, it's approved and supported by the ACI, so which is probably the most important answer to all of that. But yeah, that's a great dive there. We do have a question about recommended scan density. Somebody using an infrared scanner that does 10 points per degree. And I guess to go off what Philip just said, the way that this software works, the way you're able to replicate these tests is by having relatively dense data. You're definitely going to want, many points within a square inch. So I'm not sure how that would work with an infrared scanner doing 10 points per degree. Any quick thoughts on that, Philip?
Yeah, I mean, you probably won't be able to do ASTM E1155. It also depends on the accuracy of those points. But with lower density points, you can do heat maps and contour maps, and those contour maps, for example, are much more of a approximation of the elevation, as opposed to a distinct, distinctly obtaining extremely high accuracy points.
Yeah. We've got a couple questions here about licensing. Do you need to have a Verity license to use this? So we actually have some pricing on this. We are basically putting Rithm by itself. So if you just want Rithm without Verity, that's going to be $199 a month with an annual commitment. If you just want to buy Verity without Rithm, we have a new price point for that, which is $399 a month, and without Rithm. And then if you want them together, that's kind of the original pricing for Verity. So anybody that has bought a Verity license that is out there, basically all you need to do is email us, and we will, if you bought the kind of the full suite version of Verity prior, we will turn Rithm on for you. You just have to ask, because we got to send you a new license key. So that's pretty exciting. I'm really happy to be bringing that out to our existing customers, putting that in their hands. If you ended up picking up Verity at the lower price more recently, then we can always bump your subscription up to roll Rithm into that, and just prorate that out for the rest of your annual term. For that, reach out to sales@ClearEdge3D, or reach out to your sales rep directly. Happy to get that out into your hands. And I think with that, we are 45 minutes into the lunch hour. So I'm actually gonna wrap up here, and we've got actually a bunch more questions that came in. So what we'll do is, after the fact, we will try and follow up with everybody that asked a question but did not get it answered, and get you that information. But by all means, reach out on Twitter, reach out on LinkedIn, email us at sales@ClearEdge3D. Happy to talk to you through other channels to answer any questions y'all might have. I do want to thank Philip especially for joining us today, taking time out of his day. It was really great to have you, Philip.
Thank you. Thanks for inviting me.
Absolutely. Yes. And thank you, Zoltan. And with that, we will end the webinar. Thank you all for listening in.